Hi students, welcome to our physics channel Physics Star. In the previous class, I explained about the instantaneous axis of rotation and did two problems in that, right? So yes, two problems. And to make the concept very clear, okay, a little bit more, there is a more scope to understand by doing some other problems. Okay, so let us do few more problems today based on instantaneous axis of rotation. And okay, let us start doing the problems. Now the first one is as follows. Let me share that with you. Yes, observe this. Right. Now see here, a uniform rod of mass 2 kg and length L is kept on a smooth horizontal plane. If the ends A and B of the rod move with speeds V and 2V respectively, perpendicular to the rod, then find the, now we have to answer two questions here. First one, angular velocity of the rod and linear velocity of center of mass of the rod. And the question B is kinetic energy of the rod we need to find out. So in that first, let us discuss about how to find the angular velocity of the rod and linear velocity of center of mass of the rod. Okay. Now let us first take how to find the angular velocity of the rod. Okay. So for that purpose, now let me draw the rod. Pardon, I'm not drawing perfectly. So this is a rod. Now the top point B is moving with the velocity 2v, and the bottom point bottom point, this is A, and it is moving with the velocity v. Okay, now we need to find out angular velocity of the entire rod. Usually, yesterday already we discussed about it, right? Somehow. Okay, and now let us discuss about how to do this kind of problems. And I already told you how to draw the instantaneous axis of rotation. This is how to draw the instantaneous axis of rotation, right? Now it is at a certain distance. Let us consider it is at a certain distance x from the center. Consider this is the center of the total rod. This is x from the center. Okay, it means now I'm finding out one point here. I'm finding one point here. The point is at rest actually. It means that that point will be the instantaneous center of rotation. Center of rotation does not rotate, right? So at that point, we can say the velocity of center of mass as well as the rotational velocity both are equal. Means r omega and vcm both are equal here at that point P. Okay. It means, what does it mean? It means that that point P will be at rest while the total rod is rotating. While the total, this is rod, if it is rotating like this, there will be one point at that particular instant, there will be one point which is exactly at rest. That point is P now. Now with respect to that point, we need to find out the entire rod's angular velocity. Okay, entire rod's angular velocity we need to calculate. So now if we consider the angular velocity at these two different points. Now let us consider angular velocity at point A must be equal to angular velocity at point B with respect to the point P, which is nothing but what? That point P is instantaneous center of rotation. Okay. Now omega A is what? Omega A is, that is VA divided by, okay, which is what is a perpendicular distance? Omega is equal to V by R, right? Let us write that omega is equal to V by R for first one, for A here. So VA divided by, what is VA here? VA is V only, right? V by, what is its perpendicular distance? See, this is its perpendicular distance. Okay, how much is this? Can I write it as L by 2 minus X? Because if we consider the whole length as L, given it is L, and from the center to that end A is L by 2, right? And already X distance we have taken. So L by 2 minus X is the total distance from A to that point P, right? So V by, what is the distance now? Perpendicular distance L by 2 minus X, which is equal to omega B. What is omega B here? Again, 2V by, perpendicular distance is what? Perpendicular distance is here from this point P to point B. Means B to C it is L by 2 and again plus X. So now I can write here V gets cancelled, right? Therefore now cross multiply this. L by 2 plus X is equal to 2 into L by 2 minus X. 2 into L by 2 minus X. Now L by 2 plus X is equal to L minus 2X. Now solve this X value. 3X is equal to L by 2. L minus L by 2, you'll get L by 2 only. Therefore, X is equal to L by 6. Okay, so there will be, it means that there will be one point. It will be, okay, now there will be one point P, okay, now where the entire particles, all the particles of that rod will be in different directions of motion while it is moving. The total rod will be in a combination of translatory plus rotatory. Okay, now meanwhile, all the particles in that entire rod will have different velocities in different directions, whereas only one particle will be at rest. Only one particle will be at rest. That particle is P. Okay, that is axis instantaneous center of rotation. So it lies at how much distance now, as we have calculated? X is equal to L by 6. X value L by 6. Now, what is he asking? He is asking to find out angular velocity. So, therefore, omega is equal to, now let us take either omega A or omega B, whatever it may be. So, omega A is equal to V divided by L by 2 minus X value is how much? L by 6. So I can write V divided by, it is 6. Okay. So 3L minus L, 2L. I'm sorry, L. 3L minus L. Three L minus L divided by 6. Yes. Which is equal to 2L by 6, which is equal to L by 3, right? So 3V by L. Therefore, what is omega here? 3V by L. Means with respect to point P, the whole rod's angular velocity will be same at that instant. Whole rod's angular velocity, whatever the point you may take, the angular velocity of that particle in that entire rod will be same only. Okay. So omega is equal to 3V by L we have calculated. Now, how to find the velocity of center of mass of the rod? It is very simple to understand. We have calculated the angular velocity. Now let us calculate the velocity of center of mass. Velocity of center of mass of the rod. No one need of discussing about rotation now. We need to discuss only about translation. How is it going? In the rightward direction, it is going with 2v velocity, and in the leftward direction, it is going with v velocity. That's it. So you can write VCM is equal to, forget about all the remaining data, just 2v minus v, that's it. Which is what? V. This is velocity of center of mass. Velocity of center of mass. So this is about velocity of center of mass. Now how to calculate the kinetic energy of the rod? Okay, it is not needed now, because based on instantaneous axis of rotation we can also do it, but kinetic energy of the rod means there are two types of motions here. So linear, translational kinetic energy, that is half m into vc square, plus rotational kinetic energy half I omega square. Both are added. Okay, now if we add both of them, you will get the answer. Where while you are finding out here, I'm just saying one point here, very important point to be noted. While you're calculating the kinetic energy of the rod, okay, let us discuss about that little bit. Kinetic energy of the rod means it is nothing but the total kinetic energy. It means kinetic energy due to pure translational plus kinetic energy due to pure rotation. Pure rotation means you don't need to consider that point P. Okay. So kinetic energy due to translational, let me explain. Half m into Vc square plus half into Ic into omega square. If you are just calculating rotational kinetic energy, just keep one thing in mind, that you have to calculate according to its center of mass, half Ic into omega square. Okay. Or else if you want to calculate that entire thing, no problem. With respect to point P only, you can calculate the entire kinetic energy, no problem at all. Means you don't, this is entirely kinetic energy with respect to point P only. Understand? Okay, you may take with respect to point P, or you may take like this. But if you are taking separately kinetic energy translational plus rotation, if you are taking separately, rotational kinetic energy with respect to what I have to take the moment of inertia, with respect to center of mass we have to take the moment of inertia. Okay, therefore half m v square plus half, what is I here with respect to center of mass, ml square by 12 into omega square. What is omega? Here we have got it as 3v by 12. Yes or no? So it will be 3v by 12 whole square. Now, if we simplify this, we are going to get half into mv square plus, okay, 3 ones, 3 fours here. 16, 1 by 16 into ml square, L square gets cancelled. Ln square gets cancelled. Ml into v square. Okay, now. That's it, ml into v square. Again, LL also gets cancelled because L square, right? It is 460, 4 into 416, 16 into 2 is 32. In the denominator, we are getting 32. Let me write it clearly, I'm sorry. In the denominator, we will get 32 because 3v by 12 whole square, no? I'm sorry. Let me do it again. Or else, with respect to that point P only, let us consider that is half into directly IP into omega square. Very easy to understand. Very easy to understand. Half into IP into omega square. That is half into, what is IP here? Moment of inertia with respect to point P. That is IC plus M. Okay. what is that perpendicular distance between the two parallel axes? We with respect to P, if we want to find the moment of inertia, what I have to do now? IC plus mr square. Parallel axis theorem I have to apply, right? So from center of mass to that point P, the perpendicular distance is x. Am I right or not? So therefore I am writing it as IC plus mx square into omega square. Now substitute. You will get very easily. Half into what is IC? ml square by 12 plus m into x value already we have got, that is L by 6 whole square, L by 6 whole square into omega square is what? We have got omega square as 3v by L, 3v by L whole square. Now let us simplify this. ml square by 12 plus ml square by 36 into 9v square by L square. Yes or no? Now half into 9 v square. I'm just cancelling that L square value. Okay. Into I'm taking that m also as common. Let us take m also as common. Half into 9 into m into L square gets cancelled. mv square into 1 by 12 plus 1 by 36. Therefore, 9 by 2 mv square into 36 means here it will be 36, 3 plus 1, 4 by 36. 3 plus 1, it is 4 by 36. Therefore, total kinetic energy is equal to 9 by 2 mv square into 1 by 9. 4 by 36, 1 by 9. You know? Therefore, you will get half mv square. That's it. This is how we have to calculate the kinetic energy of that entire rod. Understand? Okay. So let us discuss the next question. That is, a uniform rod of length L is released from rest. In consequence, it rotates in vertical plane and its center of mass moves down under the action of gravity and the reaction forces offered by horizontal and vertical smooth surfaces. Find the angular speed of the rod as a function of angle theta made by it with the vertical. So at a particular instant, it is making an angle theta. Actually, it means that it is starting from almost a vertical position. It is starting from almost a vertical position like this. Let me draw it. You'll understand. See, like this. It is almost starting from a vertical position. After that, what is happening? It starts sliding like that. It starts sliding like that. Okay. So keep one thing in mind. When it is at vertical position, at the initial position, it is at a height L by 2 from the ground. Okay. Now, it is at a height L by 2 from the ground. Now I am drawing the rod, the motion of the rod at a particular instant. Right. At a particular instant, it is making an angle theta with the vertical. We know that the total length of the rod is L. Okay. Now, at that instant of time, how much height it has lost from the initial position to this position? How much height it has come down? The center of gravity comes down. While the total rod is rotating like this in anti-clockwise direction, the center of gravity will come in the downward direction. Am I right? Meanwhile, here we can say while the center of gravity or center of mass is moving down like this. Okay. Now we can say that if we want to calculate the angular speed of it by using instantaneous axis of rotation, now it is very easy when we apply law of conservation of energy by taking instantaneous axis of rotation. Okay, it is very easy to understand. We need to find out omega value, angular speed omega value in terms of angle theta. Okay, now what am I doing? I'm just taking the conservation of energy according to law of conservation of energy. Means usually, yes, it is losing the potential energy, and because of loss of potential energy, it is gaining some kinetic energy. Am I right or not? So according to law of conservation of energy, we can say that loss of potential energy is equal to gain in kinetic energy. With respect to what here, this is important. If we want to do this in a simple way, now let us consider instantaneous axis of rotation. What I have to do now? See, two perpendicular lines to be drawn from the 2 points. Two perpendicular lines to be drawn from the 2 points, so that this is that instantaneous center of rotation. Consider this point is P. This is instantaneous center of rotation. Means with respect to that point, the entire rod rotates. Okay. Now, the main thing is to find the distances. That's it. Right, from point P to this distance. This distance. Let us take the entire distance here first. From point P to the center of the rod, the distance is L by 2. Am I right or not? The distance is L by 2. And initially, the initial potential energy is what? When the rod is at vertical position, almost vertical position, then you can write that mg into L by 2. And final potential energy is what? When it is at this position, then it is final. Okay, final potential energy means this distance from the ground, we are calculating this distance. How much is that? That distance is mg into L by 2 cos theta. Can I write like this? Observe that carefully. L by 2 cos theta. Why? Why? Because if this angle is theta, then this angle is also theta. So I can take L by 2 cos theta as the distance what I'm showing now, right? So initial potential energy I have taken and final potential energy I have taken. Therefore, what is loss of potential energy? Delta U, loss of potential energy is mg L by 2 minus mg L by 2 cos theta. Therefore, if I take mg L by 2 as common, so that I can get mg L by 2 into 1 minus cos theta. Yes or no? Now this is change in potential energy, I mean loss in potential energy. Now let us find the gain in kinetic energy. This is important. Gain in kinetic energy with respect to what I have to do? With respect to point P I have to do. That is initial kinetic energy is, however, it is zero because it is starting from rest. Initially it is in this position. Later on, while it is sliding, it comes like this. Am I right or not? So half into initial kinetic energy is zero. Now final kinetic energy I'm taking. Delta Ke, let us write directly. Half into Ip into omega square. Now finding Ip is important now. Half into, now how to find that Ip value? What is moment of inertia at that with respect to that point? We can take parallel axis theorem, right? One axis is passing through the center of mass of the total rod and the other axis is passing through that point P. Consider that point, the moment of inertia about that point P is I naught. So I naught is equal to, or else IP is equal to IC plus, okay, M into what is R here, L by 2. Am I right or not? What is R here? The distance between the two parallel axes. Where are those two parallel axes? Again, I am showing. See, this is one axis which is passing through center, and this is another axis which is passing through that point P. Both are parallel. So we can apply parallel axis theorem. So IC plus M into R value is what? What is the perpendicular distance between these two parallel axes? L by 2, right? So I can write L by 2 whole square into omega square. Let us simplify this, which is equal to half into, what is IC value? IC is ml square by 12 plus ml square by 4 into omega square. Now finally, I can write half into ml square by 3 omega square. This is loss in kinetic energy. Now, therefore, according to law of conservation of energy, loss in potential energy is equal to gain in kinetic energy. So loss in potential energy is what? mgl by 2 into 1 minus cos theta is equal to, what is gain in kinetic energy? Gain in kinetic energy is half into ml square by 3 into omega square. Here m gets cancelled. L and here square. Okay. So now let us simplify this. G by 2 into 1 minus cos theta is equal to L omega square by 6. Or else 2 also, take 2 also gets cancelled. So that G into 1 minus cos theta is equal to, here you have to get what? L omega square by 3. Therefore, omega square is equal to 3g into 1 minus cos theta divided by L. And hence, omega can be written as, therefore, omega can be written as root of 3g into 1 minus cos theta divided by L. That's it. Understand? 3g by L into 1 minus cos theta. See how we are finding out the angular velocity by applying law of conservation of energy here. And while we are applying law of conservation of energy, okay, we are taking the instantaneous axis of rotation as, with respect to instantaneous axis of rotation, we are calculating that, right? Kinetic energy. Okay. So see, this is that. Once observe this total problem. This is that entire problem. Observe these ones. Okay, thank you. And please do like, share and subscribe to my channel, and keep watching my videos so that you'll gain more conceptual knowledge, as well as you'll gain more knowledge about how to do the problems, right? Thank you. Bye.